This video is about finding the area of composite figures. Composite figures are figures that are made up of more than one shape. By one shape, I mean more than a square or more than a rectangle, a circle, semicircle. They're made up of multiple figures. We see this shape that's not a square or rectangle, although it looks like it could have squares, rectangles, maybe parallelogram, rhombi. And what we're going to do is we're going to cut this figure into more than one shape that we can work with. Different shapes right here. We see one rectangle here and another larger rectangle here. And what we want to do is we want to be able to find the area of this one rectangle and then add the area of this rectangle to find the total area. Now we see that we've put some numbers in here, and what we want to do is find out the area of these two rectangles. And this one, area is going to equal to, and because it's a rectangle, it's base times height. This is also a rectangle, so we're going to use base times height. Base times height here, the base is going to be 6. Remember, we have to have a right angle. So this side is 6 times the height is 5. That equals 30 inches squared. Down here we see that this one is 5 by 11. So the base is 11 times the height is 5 equals 55 inches squared. All right, so let's add these together, see how we're going to add them together. So this was equal to 30, this was equal to 55, and when we add those together, we get 85 inches squared. Okay, so that's just a simple example of how to find area of a composite figure. Now remember, I'm finding the area of this one first, and then this one, and combining them and adding them at that point. Here's an interesting shape. It's kind of unusual. You see this slanting piece and then this piece that curves. And when we put this together and we try to see what those shapes can be, again, we could come up with different things. We could cut this, get a triangle, and a rectangle. I think that's a little complicated, so what I'm going to do is I'm going to use the idea of our parallelogram. Remember, the area of parallelogram is still base times height, and the area of a semicircle. Okay, I added some numbers here. I decided that this is going to be 14 kilometers, and if this side is, of course, if this is a parallelogram, that means that this is 14 kilometers, and up here it's also 14 kilometers. So this diameter is going to be 14. Remember, that's a diameter. All right, this is going to be 6. Remember, it's base times height for our parallelogram right here. All right, and so we're going to put down base is equal to 14. Our height is going to be 6. And let me make that a little bit more clear. So 14 times 6 is 84 kilometers squared. We're going to use that number. Okay, so this is our answer for the area here. Now, for our semicircle, because it's half of a circle, I'm going to take half of the area of a circle. So remember, area of circle is pi r squared. I'm going to use an approximation. I'm going to use pi is equal to 3 just to make the math easier. Remember, whatever our answer is, it's actually going to be greater because pi is actually 3.14 in the 7th grade. All right, let's put some numbers in. I want 1/2 of pi, 3, times the radius. This is diameter, so I want the radius. I'm going to need half of 14. Half of 14 is 7, so that means 7 times 7. Okay. All right, let's solve this. 1/2 of, let's see, 7 times 7 is 49. 49 times 3 is 147. All I did was multiply these, okay? 147. I want half of that. Remember, that means divided by 2. So half of that is going to be 73.5 kilometers squared. Now, once again, I'm going to have to add the areas. So the area of my parallelogram plus the area of my semicircle. Okay, so that's 84 plus 73.5. Remember, it's kilometers squared. When we add these, we're going to get 157.5 kilometers squared.